right, so here is dimensional change in 3D, and this can get a little complicated. Hopefully I can simplify it for you. So here we're going to find the surface area and volume of the cylinder when R is 3. So I'm going to go ahead and just write that in the picture real quick. So your radius is going to be 3, so let's say this is 3, and the height is 15. So round your answer to the nearest tenth. So this is easy. We've done this before. You got to find your formulas that you need. And so for the surface area formula, it's for a cylinder is 2 pi RH plus 2 pi r squared, because we got two circles there, 2 pi r squared. They gave us the radius, so this is just a plug-in problem. And so we would replace our unknowns with what we do know now. That's a weird looking 2. Let me do that again. Okay, and so we know that your radius is 3 and your height is 15, like so. And so you're going to plug this into the calculator and you're going to get 339.3. And so that would be your surface area, and it's inches, so it'd be inches squared. Now we do the volume. Remember, volume is always the area of the base times the height. The shape of the base is a circle, so it would be pi r squared. That's the base, area of the base, times your height. We know what your r is, so we're just going to replace that with 3, and your height is 15. You put that in a calculator, and you're going to get 424.1. Just remember, I'm rounding to the nearest tenth. All right, so that's the original cylinder. Now, let's see what happens to these numbers when we double the radius. So let's double the radius, and we're going to see what the new surface area and volume is going to be. And we're going to describe the effects of this dimension change. So we're going to use the same formula that we did before. But remember, instead of the radius being 3 like it was just now it's going to be 6. Why? Because we basically took the original and we multiplied it by 2. Okay, and your height remains the same. Okay, so remember the formula is 2 pi RH plus 2 pi r squared. We're going to do the same thing we just did. I always use parentheses before I plug it in. Okay, and so we know that your radius now is 6. Your height is still 15. Your radius is 6. You plug that into a calculator and you should get 791.7. All right, that's inches squared. Let's do the volume. The volume is going to be the area of the base, which is pi r squared times your height. And then your radius, remember, has changed to 6, and your height remains the same. Put that in a calculator, and you get 1,696.5, rounded to the nearest tenth. And that's cubic inches. All right, so let's see what's happening here. Well, if we look at just this part of your surface area equation, before that number was 3. If you compare what you get, for example, if you replace this 6 with a 3, you're going to notice something. And let's actually go and do that. So I'm going to go ahead into my calculator here, and I'm going to put, in this calculator, I'm going to show you the difference. So it was 2 pi. Before it used to be 3 squared, right? And that gave us 56 point right? So let's do now 2 pi. Let's put 6 squared and see what happens. Well, now we get 226. What happens, let's see how we can notice what's going on here. Let's take that number, like I said, to see if there is some type of relationship. How much bigger did the area of the circle become? I'm going to take the new number and divide it by what it used to be. And it's going to give me a perfect, beautiful number 4. That means that the area of the circle for this cylinder became 4 times bigger. It actually, we increased it 4 times. And so that's what we're going to put here. It got the bases, the area of the bases got 4 times bigger. Now let's compare the volumes. And so from here we're going to go back to the first picture, or this picture right here. The original volume was 424.1. If you take that number, 424.1, if we took 424.1 and we divided it by our new volume, or actually we did the other way around, and we took 1696.5 and we divided it by 424.1, we are going to also get 4. And so we can know then that from the first volume to our second volume, the number went up 4 times. It got 4 times larger. Okay? Hopefully that makes sense. And this was when we only changed one dimension. But what happens if we change both dimensions? If we changed both dimensions, we would go through the same process. I'm just going to skip through here. And you would use the same formula to find your surface area. And so the surface area, the new surface area, I'm just going to go ahead and give you the number, because by now you should be able to figure it out. So 1357.2. That's the new surface area. Okay? So then you would have to find the new volume. And remember, this is when you double both the radius and the height. So remember, your new radius would be 6. And if I double the height, it would be 30, right? Because that's 15 times 2. And this would be 3 times 2. Okay, so these are the numbers you're looking at right now and what you would plug into the equation. So your volume, your new volume is going to be 3,392.9. Okay, so after you plug it into the formula, then we compare. And the way we compare is just like we did before. We would divide the numbers and see what's going on here. Okay, so the new surface area, that's the number we just got. And the new volume, that's where it would go here. Now here, to compare the surface area and what happened here with the changes, we can, first, we can write down the new surface area number, 1357.2. And we can divide it by the previous surface area number, from the very, very first thing we did, and we can say, okay, well, the surface area used to be 339.3. So how did we get from 339 to 1357? Well, we can divide the two numbers and get our answer. So if we divide those numbers together, we'll get 4. So that means that it got 4 times bigger. If I take 4 and multiply it to 339.3, we're going to get this number. And so it got 4 times bigger. The surface area in total. We're not just looking at the bases, because we changed both the base and the height, the radius and the height. We changed everything, the whole figure. So now we look at the volume, and we can do the same thing with the volume. And for the volume, you're going to do the same thing. You take your new volume, 3,392, excuse me, and we can divide it also by what it used to be. And what it used to be was 424.1. And so by how much did it get bigger? And this time you're going to get a big number. This time the volume did not just get 4 times bigger like what we just did. It got 8 times bigger. So this is something to remember. If you only change one dimension, the volume in this case, it gets just 4 times bigger. But if we change both dimensions, the volume is going to become 8 times bigger. Okay, so this is just an analyzing type of a situation. So I hope that makes sense.